going to start things off and then hand them over to Fraser, who's
You,
really the master of
you get,
ceremonies around here.
wait, what? You're gonna hand something over to me?
just the orchestrating of the stream, because really you are the master of streams.
I
Um,
I don't understand. What do you need me to do?
I run Astronomy Cast. So this is our 16 of the CosmoQuest Hangoutathon. Fraser, are you in the correct panel?
Am I in the correct panel? You mean, am I in the correct panel for recording? What do you need?
Yeah. So we're about to record Astronomy Cast, missions to
Okay.
the outer solar system,
Yes.
and then
Yeah.
after this is No Man's Sky. I
Okay.
got him so excited with discussions of doing No Man's Sky that he completely forgot there was an Astronomy Cast right
No, I knew we were going to do an
before.
astronomy cast in a No Man's Sky, but I don't actually play No Man's Sky on the computer. And so I had to spend about 15 minutes understanding how to play it on the computer. And I don't think I can make the sound come through, unfortunately.
Oh no.
Yeah, I can't think of a way to make the sound happen. I mean, I can think of a way to make the sound happen, but it would require wires and dongles and things. So it might be silent, which,
Okay, so
yeah, yeah.
so if needs be, can you share it into our Discord and we'll just grab the sound and everything else from Discord?
I don't know. Like join the Discord, share into Discord. I don't even know how to do that.
Oh, it's just magic.
You
It's
kids,
fine. It's
you
fine.
kids these days.
We're only like a couple of years apart. Like Fraser and my husband were in university together. They didn't know it at the time. We figured that out later. But he still likes to mock me periodically because I did not exist during any of the Apollo era.
Right. You always say like, oh yeah, we weren't born for the Apollo missions. Like, whoa, whoa, whoa. One of us was born for some of them. Uh,
All right,
uh,
so for those of you who don't know what you've stumbled into, this is the CosmoQuest Hangoutathon Volume 2, 2023. We are working to raise money for all the programs that we do. And Astronomy Cast has seen its Patreon numbers go down, like everything right now.
mm,
And we're doing okay. CosmoQuest less so. We didn't have the same
mm.
buffer. And so this weekend, we're trying to raise funds to keep everything going solid and strong. And we're taking advantage of this event to record what would be Monday's Astronomy Cast because I plan to sleep.
Good call.
And
Yeah.
and we're also going to record next Monday's Astronomy Cast because Fraser is going on adventures.
Yeah. On the road. So, I mean, I could probably make it happen, but I would be in some hotel. So better to not.
We are old enough to recognize that is the foolishness of the young.
Well, it's just you can't, like, technology sucks. You can't trust it.
Yeah. I love that we're finally willing to say that, but back in like 2008, we were not.
Yeah. Oh no, I'll get a hotel and then I'll stream from the hotel and it'll be fine. And it's not fine. And you're 15 minutes
No.
late and the connection is garbage. And no, it's a gigabit. Thank you very much. Wired machine, fast computer, good camera, gigabit internet. Yes, please.
And this is where we live now.
So how do you want to do that? Are you streaming out on YouTube as well, or just on Twitch right now?
I'm on the CosmoQuest YouTube right now because I couldn't sign out and sign in gracefully
Okay.
without killing Twitch.
Okay. All
So
right.
we will move the video.
Okay.
But we are on
Um.
YouTube. Just
Yes. Just not on one that I have. Okay. Yeah. I'm just sort of thinking how I'm going to get access to chat when we get into the questions
oh,
portion of things. But that's
let
fine.
me
It's fine. Don't
let
worry
me
about it.
just I can
You
give you
can
the
you can
link.
ask the questions later on. So we'll
Okay.
yeah.
Okay.
Let's just make our show and then we'll go from there.
Alrighty. I am trying to find the window that we record the audio in. Whoa. There it is. This is episode 698.
697.
Okay, I lied to myself. It's okay. I can fix
Yep,
these
697.
things. 697. All right, I'm ready to press all the records.
All right.
Pressing the first record. Watching it yell at me. All right.
Dare you?
Well, it's like, where do you want me to save this file is what it is literally yelling at me. I apparently forgot to tell it, because this is not our normal account, exactly where it should put the file. So for those of you new to Astronomy Cast, welcome. We start every episode, and we always have, acknowledging that technology is hard. Not quite as hard as space.
Well, hello. Technology sucks. That's the problem.
Yeah.
Space is trying to kill you. Technology just wants to break.
It's lazy. It's very, very lazy. All right, so unable to complete the output configuration. What are you doing?
For audio or video? I'm going to stop my audio.
No, it's going. I don't know what it's being upset about. Okay, it's done being upset. We are going out on YouTube. We are going out on Twitch. I may have to pull. Now it will record. Okay, it just needed me to be confused by it. So the video is recording. I am now going to start my audio. My audio is recording. Miracles
my audio
have occurred.
is also recording. Okay.
All right.
Let us begin. Astronomy Cast, episode 697, Mission Roll Call, Part 6, The Outer Solar System and Beyond. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pam, how you doing?
I am doing well. This is one of two very special episodes of Astronomy Cast. We are filming this during the it's a very special episode of Astronomy Cast that's going out during the CosmoQuest Hangout-a-thon. We're spending 32 hours, not contiguous, we're going to sleep, trying to raise money to keep all of our programs going, all of our people fed, and we just want to give all that we create away for free. And I was a little slower to add ads than Fraser, so we have to beg right now. So thank you everyone who's here and is enjoying everything we're doing. We're now going to get on and go strictly science, science, science.
All right, let's get into it. But first, we should take a break. And we're back. Finally, we reach the end of our tour through the moons in the solar system, out beyond Mars, to Jupiter, the Kuiper Belt, and beyond. So this is the final episode where we talk about all the spacecraft that are in the solar system. We reached Mars, and now we push out beyond Mars. And the first spacecraft that I guess we'll reach is the one that actually dropped a bunch of news just a couple of days ago before we are recording this episode, and that's Lucy.
Lucy knocked all of our socks off. I'm Facebook friends with Dr. Stuart Robbins at Southwest Research Institute, and I saw this, sub post, I don't know what you call it, where he's like, okay, so Lucy's gonna have images tomorrow, and then just facial expressions in emoji.
Right.
I'm paraphrasing terribly. And I was like, okay, so something's coming. I rearranged our news plans for this week to make sure there was space. And I was expecting it to be like another rubble pile, a dog bone, just some weird shape. But no rubble pile for us. But instead we got 2 asteroids. The main asteroid, Dinkimesh. Am I saying this halfway right?
I think that's right. Dinklage. I always just think Dinklage, but you know, one is an actor in Game of Thrones, the other is the name of an asteroid with deep cultural heritage. So yeah, I
Exactly.
think Dinkimesh is yeah.
Most people call it Dinky.
Dinky, sure.
All right.
But what
So
do you call moon? If Dinky is
Dinky
the main
Moon.
asteroid. Dinky moon, that makes sense. All right. Yeah.
So Dinky's about 700 meters across. It's a bit bigger than Bennu, and they noticed that the variations in brightness were more than they were expecting. We knew it varied in brightness. This was thought previously to just be its rotation rate. But the variation had them thinking, well, what if this is actually a binary system? And sure enough, there's a 220 meter companion. And during closest approach image, they got this wonderful suite of the bigger one in the foreground and the smaller one just slightly peeking out. Well, it's just slightly overlapping with the foreground one. So you have this great perspective of just how closely they're orbiting each other. And I love just how much we're finding. No one really likes to be alone in space. Galaxies, asteroids, planets.
Yep.
Things group up.
And like the question is starting to be like, how do you get these things? Are they spinning up? Because like back to Dimorphos and Didymus, which the DART mission slammed into Dimorphos, like it's really starting to look like Dimorphos is a piece of Didymus, that some event causes an asteroid to spin, maybe the Yorp, you know, the interactions with the sunlight makes them spin faster and faster, and then chunks start to shred off. And we saw even with Bennu, it was spinning at pretty much the maximum speed, that there are rocks that were lifting off of Bennu, going into orbit, and then finding their way to more northern or southern latitudes, and then being attracted again and landing on the surface. And then, in fact, that asteroid is shedding material at its equator and then pulling it back in to the northern and southern parts of the asteroid. So, like, this dynamic is really fascinating, and you sort of wonder, are we going to see more and more of this? I mean, I think we're up to 11 objects seen or that Lucy will visit known so far, with many of the objects having additional moons.
And they only thought they were going to see 9.
Have moons? Yeah, exactly. And now we're up to, are they all going to have moons?
Yes, please.
Yes, please. Yeah, exactly. All right. Now, I actually don't know where this spacecraft is, but let's talk about JUICE.
JUICE is on it. I mean, this is going to come up a bunch during this mission because, like, you would think Lucy in the asteroid belt going to Jupiter is like straight line in it, but no. Lucy's going to turn around, come back. The next thing it's going to see is us. Well, maybe not us, but our planet. And then it's going to head back out after a gravitational assist. So these outer solar system missions, unless you pull up NASA Eyes on the Skies, which if I did right now would destroy our streaming setup, you can't keep track of where they are. And JUICE is on its way to Jupiter. And so this is yet another of what will be many on its way, but not quite there yet, missions in the outer solar system, because we finally realized these things need to be visited.
Yes.
But things haven't got there yet.
Yeah. And I mean, JUICE is great. I am really excited about JUICE. I mean, I'm excited about the Europa Clipper. I'm excited by all of them. But with JUICE, they're going to do these flybys of each of Jupiter's icy moons, Callisto, Europa, and Ganymede. And they're going to do like a few flybys of Europa and Callisto, but then it's going to go into orbit around Ganymede and stay there. And like the more that I learn about Ganymede, the more excited I get about this world. It is the largest moon in the solar system. It is bigger than Mercury. It has a magnetosphere. It has a thin oxygen atmosphere. It has that same issue of an ice shell with liquid water ocean underneath around a rocky core mantle. So there's probably the raw ingredients for life mixed in with the water, but it's larger, has more gravity, and it's farther away from Jupiter. So it doesn't have that same radiation load on this. So I think the new Europa.
And Ganymede doesn't have that really weird alien look that Europa has. It looks much more like just a beat up gray ball. And so it's going to be amazing to see just what do we learn when we finally get truly high resolution images. And Juno's great. Juno, I think we now need to pay attention to. In this episode, you should have already been paying attention to it in real life. The Juno mission is already at Jupiter, and 2023 is the year of Io. As it goes round and round, it is almost on a monthly basis getting a little bit closer and a little bit closer as it passes Io on a converging path, such that later in the year it will make its closest approach. And with each pass, it's giving us a little bit more of Io in a little bit more detail, with amazing images coming from the folks like Ted Strike, who are processing this image to bring out the features, and others are doing what they can to enhance them. There was an overly enhanced version on Astronomy Picture of the Day the other day. Go get the stuff directly from Ted. It's amazing.
The images of Io?
Yeah.
Yeah.
But we're not going to get what we're going to get with Juice. Juice is dedicated. It's there for the ice, not the world.
Mm-hmm. Yeah, and with the Juno mission, like the original goal was to do imaging of Jupiter, to study its upper atmosphere, to measure its magnetosphere and the radiation environment around Jupiter, all of these things. And of course, the amazing story that we've talked about with Juno is that they weren't originally planning to put a visible light camera on it. And then
it's an EPO camera. It's for education and public outreach.
Yeah.
The science it's doing.
Yeah, I mean, so it was a bit of an afterthought, but they were able to put it on, and it's able to do visible light as well as near infrared.
Yeah.
And so you get these really great images of Jupiter, and like all of these, the cool pictures of Jupiter with the swirling clouds and the incredible structures that you see. This is all coming from Juno, and as you said, as an EPO camera, you've got all of these citizen scientists who are watching every time Juno makes this flyby of Jupiter, downloading all the fresh images, processing them, using all of their skills, and just producing amazing images. And like some of my favorite citizen scientist people are working on this, and they're making discoveries at Jupiter with their work.
Polar vortices. We're discovering the clouds at Jupiter are swirling and interacting and chemically interesting in ways we just didn't know. It's amazing.
Yeah. And so on that most recent flyby of Io, astronomers were able to measure 266 volcanoes in the pictures of Io from the flyby. Now it probably has some more, but that's how many they were able to see. And what's amazing about that is then, they're really starting to think there's this global magma ocean underneath the surface on Io, and that all of these volcanoes are connected, and that you've got this magma flowing and then erupting in various volcanoes. And it is the most volcanic place in the solar system, way more volcanic than Earth. That flyby that they just did, the one that was about a month ago, they came within about 15,000 kilometers of Io. They've got another one planned later on this year, and the one that's coming in 2024 is going to be 1,500 kilometers away from Io. Like this is going to be quite the flyby, and the spacecraft is still doing fine. I mean, they brought it close to Jupiter to try and go through, and they're risking it in this radiative environment, but still amazing.
Yeah. We run out of adjectives occasionally, folks.
Right. Well, it just tells us that we really just need more at the outer solar system. Like, unfortunately, we don't have a lot to talk about today. We're almost halfway through, but we will talk about some more spacecraft in a second. But it's time for another break, and we're back. All right. So, were there any spacecraft that were on their way that we missed to the outer solar system?
So, what do we say about IBEX? I mean, it's just like hanging out
It exists. It functions.
Yeah, this is
Yeah.
like the least exciting, most exciting mission ever. There is a mission called IBEX on a journey to the outer solar system where it will hang out in basically a kind of solarish orbit, looking at the outskirts of our solar system. That's all I've got. I don't know what else to say about
I don't
it.
have anything additional for that. It's a NASA mission,
It's
right?
a NASA mission.
And it's been around for a while.
It's been around since 2008. It launched
Yeah.
in 2008. Yeah, it launched on a Pegasus rocket dropped from an aircraft, which you don't get outer solar system explorers that usually launch on anything other than extremely heavy lift vehicles. Yeah,
Oh, well, moving on. Where do you want to go next? I guess New Horizons.
that works.
Rosetta's dead, right?
Rosetta is not returning data at the moment. I never
Yeah.
count a mission as dead until like it burns up somewhere.
Right, right. But it is no longer returning data. Yeah,
Yeah.
I think it's yeah, well, let's move out to New Horizons then.
So, New Horizons, as many of you probably know, launched prior to the 2006 decision that Pluto is no longer a planet. In 2015, it made its historic pass of Pluto and Charon. It has since gone on to visit two different, is it still only two?
No, just one.
Just one. I lied. Okay.
Yeah,
It has,
Arrokoth.
it has since gone past Arrokoth, which I guess it changed names enough times that I decided that it was
Right.
two different objects, which is a basically conjoined icy blob, the snowman in the outer solar
Mhm.
system. And at this point, NASA's decided that rather than continuing the mission to visit additional Kuiper Belt objects, they will instead focus on helioscience and looking back in to the inner solar system. There's a lot of thoughts being vocally stated at senior review meetings right now, where the planetary science community would still love to keep their hands on this mission, still love to send it off to anything that we can manage to find out there, and just keep trying to get more data on these objects that we have nothing else we can visit with.
Well, you know they extended it to 2029, right?
Right, but the funding is to do helioscience.
But that still gives them an option if, say,
Yes.
Vera Rubin finds another Kuiper Belt object that is in
Exactly.
their flight path, then they can still swing towards it. I mean, obviously, New Horizons, we always, for all of the planets in the solar system, we had close-up pictures of all of them. We had pictures of, thanks to the Voyager spacecraft, which we'll talk about in a second, we had images of Uranus and Neptune. But the one that for us growing up in our picture books, Pluto was an artist's illustration, or it was 8 pixels from the Hubble Space Telescope. And it just was an unsatisfying image. And then in 2015, they did the flyby. Like it's been a while since they actually did the flyby of Pluto and Charon.
2015.
And we got to see these close-up images of these two worlds for the first time ever. And
revolutionized.
Pluto is such a different place than I think anyone expected. It's going to be so far out. It's going to be this cold ice ball, but no, mountains of ice. There's made methane and ammonia that shift across the surface. It's probably got cryovolcanoes.
Yes.
In fact, astronomers recently think they might have seen a super volcano, which I know you like to hear about.
Cells.
Yeah. And they're catching Pluto in this time when it is starting to shift away from the sun, that its atmosphere is about to freeze off onto the surface of the world. But you got those incredible pictures moving away, seeing this thin blue atmosphere around Pluto. And then Charon itself is such an interesting object as well. So I
Vast
mean, just
chasms. Like you
yeah,
can
what a huge
see
update.
these when you look at a world and you see a notch taken out because that's where a valley is. More of this, please. I'm
Yeah,
just going to
yeah.
keep
Well,
saying that.
and there are so many of these other objects out there. There's Eris, there's
Yeah.
Sedna, there's Quawar, there's Gong Gong. There's like all of these objects out
Haimea
there.
with its moons and its rapid rotation.
Yeah. Yeah. And like we need to go back. And there was some recent study with Webb where they looked at them and they look different from each other. Like they're not like none of these things are the same. And each one needs to be visited. Each one is its own special butterfly that we need to go back to. But one of the cool things, you're talking about it doing heliospheric science. Like one of the really cool projects that they recently had New Horizons do was look into the universe from this unique perspective out beyond. Were you following this story?
Not as much as you, so go ahead.
Yeah. So one of the big questions that astronomers have always had is how much light pollution are we getting in the inner solar system? Because we are trapped inside the inner solar system.
Mm-hmm.
All that zodiacal dust, there's a lot of stuff that's left over from the solar system. But once you get out into the outer solar system, then you are beyond this light pollution. And now you're getting the most pristine view of the universe. And the only telescope in the solar, capable of making these observations is the instrument on board New Horizons. And so they were able to image just the universe itself and then compare the amount of sky glow that they were getting from those images compared to what astronomers see farther into the solar system, and then use that then make better estimates about the amount of galaxies and dust and all of that that's out there in the universe. And so without New Horizons, like this would be worth sending a telescope out to do all on its own to get these kinds of observations and give us this baseline for the darkness. And so now we know how dark the universe truly is. And I don't know if you get this question. People always ask me this question, like, oh, should we put a telescope? Would it make sense to put a telescope out at, say, Neptune? And my answer had always been no, like there's no value to go, like once you're in space, you're in space. It's fine. But I'm wrong. I was wrong that it is darker out at Neptune, and that you will get darker, clearer skies. You'll get a better view to the universe. And for certain kinds of observations, that's what you need. All right. We're going to talk about, I guess, some of the longest running spacecraft in a second.
Yeah.
But it's time for another break. All right. Let's talk about the Voyagers.
So these, go ahead.
I was going to say, I mean, give me your memories of the Voyagers.
So I was like early elementary school when they went through the Jupiter system. And I think you really have to say Jupiter system, given those moons are worlds in their own right, with Ganymede being bigger than Mercury. And one of my earliest memories is getting into a fight over whether or not I had to take a nap, because we were going to stay up and watch the images come back and be on TV. And I was little. And from that point on, it was like I was going to stubbornly watch every image that ever came back from that mission. And throughout my life, event after event was just bookmarked. And the one that makes me sad is the Uranus encounter was just a couple of days before the Challenger disaster. And so it just like completely got lost in the news. And I mean, admittedly, Uranus is basically a really nice teal ball, but still, this is the entirety of my life in a way. World after world getting encountered by these outward traveling missions.
Yeah, the Neptune one was more meaningful for me. That was in 1989. Uranus was in 86.
Yeah.
Voyager 2 reached Neptune in 89. Now, I was in my final year of high school, and it was in the newspaper, and we were sitting on the bus coming back from school, and a bunch of my friends were big nerds, and so we were geeking out about Neptune and the images. And I just remember this so vividly about being so excited, because I remember those original flybys of Saturn and Jupiter, 1977. I was like 6 years old, so I even remember the launch.
Yeah.
And then just grew up with space. People are listening to now, like you have your version of that, but I think for me and Pamela, it's the Voyagers, and they
Right.
have been there side by side with us through our entire lives. You know,
And
I'm
it's
52 now,
it's
and
this
they're
wild
still going.
metaphor. They're still going, but they're starting to fall apart. And
Mm,
like, me too,
sweet.
Voyager.
Yeah, mood.
and, and so earlier this year we got news that with Voyager 2 they were figuring out, okay, so we want to keep them going as long as possible. We want to keep doing as much science as possible. And so they're just like one by one turning off different instruments, trying to keep the heat going, the warmth going, the antennas powered so they can keep sending us back data. They have managed to, I don't know how many times, recover these two little missions from safe mode. I just love that they're like, okay, so we don't need your cameras anymore. Off. All right,
Right. Yeah.
power's going to other things. Okay, we don't need this thing anymore. You have definitely passed the heliopause. Off. It's kind of merciless,
Mm-hmm.
but for the purpose of just keeping it going and going. And there was this wild time that you probably remember as well, where it felt like every other year we were like, and now the Voyagers have actually left the solar system. And the problem was that they were doing this when our sun was being erratic. And when the sun got really active, the magnetic field expanded out and protected a larger volume of space and re-encompassed the Voyagers.
Mm-hmm.
Sun calmed itself down a little bit, solar system got a little bit smaller, and the Voyagers were no longer within that protective shell. Well, at this point, I mean, we're admittedly going into solar maximum, so we could be proven wrong. But as far as we know, they're out. They're
Mm-hmm.
seeing particle fluxes, they're seeing magnetic field behaviors that are not what was measured within that magnetic safety net. They're out there in interstellar space.
Yeah, yeah. I mean, to anthropomorphize them at this point, as you said, you know, because their energy system uses this decaying chunk of plutonium that is down to just a fraction of the heat output that they began with, they don't have a lot of watts to work with. And so, as you said, they've been shutting down the instruments one after the other, taking away their senses. You know, maybe they had 10 instruments in the beginning. I don't know the exact number. And then they shut off this, they shut off the camera, they shut off this other thing. And they're left with now just feeling the wind.
Yeah.
Feeling the wind of space, and feeling whether they're in the solar system, and feeling the particles streaming from the solar wind. And now they're out of that, and now they're just feeling the collective interstellar winds from all of the stars around us.
But they were able to keep doing that in the most ridiculous of ways. They were like, okay, how do we keep powering this science instrument? And so they powered off a variable voltage safety filter. And so now they're going to have some variable voltage, but it's preferable to have variable voltage and data than no data.
Yeah. And just enough to power their transmitter, send it home, receive new commands, and continue to, you know, deaf, blind, sort of pushing their way through interstellar wind.
But shouty in the radio. It's still shouting home.
Right. Yeah. Well, that's what I mean. They're still able to yell back what it's hearing, what it's seeing out there. And I love it. So, you know, it won't be much longer, though, probably another couple of years. And then they will, in the end, have to shut down either Voyager 1 or Voyager 2. And then the other one will be shut down. And then we will lose our companions in our science communication lives, our entire lives. And yeah, sucks, but there you are. Well, that wraps up our journey through the solar system, the active spacecraft. I know a bunch. Let's about tests, like ones that are in weird orbits that are in strange places. And so I apologize to all of the spacecraft that we missed. We love you too.
It's
But
true.
yeah, but that was a lot of fun. All right. Thanks, Pamela.
Thank you. And thank you so much to all of our patrons who are out there supporting us week after week, month after month. I wish I could read all of your names every episode, but I can't. We do, however, have a special Patreon tier where if you give enough each month, and the same is true with CosmoQuest, I will attempt to pronounce your name in our podcast. This week's people whose names I shall attempt to pronounce are Jeff Collins, Simon Parton, Stuart Mills, Jeremy Kerwin, Kellyanne and David Parker, Harold Bargenhagen, Greg Davis, Alex Cohen, Kinsaya Penflienko, Claudia Mastriani, MHW 1961, Supersymmetrical, Matt Rucker, Shersam, Mark Stephen Raznak, Antisor, Abraham Contrell, Paul L. Hayden, Stephen Coffey, Alex Rain, Andrew Stevenson, Benjamin Carrier, Frank Tippin, Bart Flaherty, The Lonely Sand Person, Jim Schooler, Tim McMacken, Gregory Singleton, Kenneth Ryan, Michael Regan, and Ninja Nick. You allow us to do what we do. Thank you so much, and thank you for forgiving my lack of phonics week after week.
Thanks, everyone, and we'll see you next week.
Bye-bye. And then they saved. We saving. All right, so I have all of the chats in front of me. Let me see if I can find any questions. As always, if you have a question and you're on Twitch, we have the happy little I have a question emote that will make finding your question a whole lot easier. Let's see. Stealth scientists robbing rich people so we can do science. You know, I'd be okay with that at this point in the day. So Broken Symmetry writes, hey Juice, data to save. You were made to go out and measure. And I shouldn't be allowed to sing. Very simply, I should not.
Yeah,
but no, that's all he wrote. And I just really need Broken Symmetry to now rewrite the entirety of that song so we can give it to Beth, who actually can sing, and do a fabulous parody.
Sing. Maybe the PT thing. Do you write it?
You are really chopping up.
Yeah, I think it's up.
Starlink is not our friend today.
Of Starlink, not Starlink.
Oh, okay. Your internet is not our friend today.
Okay, I will up later then.
Okay.
Am I up there?
So Broken Symmetry asks, why shut them down? Why not let them fade out? I mean, in general, we do mostly let the missions fade away, but in a few cases, we'll put them into a special shutdown mode in hopes that someday we can call them back into service. This was done extraordinarily successfully with the WISE infrared telescope that was put into a parking orbit, was put into a parking mode, and then got picked up for entirely different research projects run by a new team as the NEOWISE mission that is turning up comets and all sorts of other things out there. Thank you for the bits, Broken Symmetry. Thank you for the bits. All right, so Arjun asks, how long would it take New Horizons to get to where they currently are? Does New Horizons go faster? New Horizons is going faster, but in a different direction. So
No, New Horizons can never get faster than Voyager 1. Voyager 1 is the fastest spacecraft.
Oh,
will
really?
Always be. Yeah. So New Horizons
I lied.
Was able to make its journey relatively quickly to get out there, but it didn't do the same number of flybys so Voyager
right.
1 did Voyager 1 and 2 did flybys of both Jupiter and Saturn, New Horizons only did a flyby of Jupiter.
So it was one of the fastest out of Earth, and then it's not as fast comparatively now in its journey.
Right, exactly. Yeah. So it went fast in the beginning, but then had to slow down.
So Zapfan is pointing out, Alan Stern said New Horizons could function until 2050. May we be so lucky.
Yeah, it's possible that Alan Stern was against the decline of funding for New Horizons and was for the return of funding for New Horizons.
Yeah.
Yeah.
Yeah. So he is now at Southwest Research Institute, and
well, he's actually I think he's in New Mexico right now, having completed his flight on Virgin Galactic.
Right.
I think that happened Friday.
I have been on stream.
Oh, well, there you go. Yeah. Yeah. So they did a flyby of, he went on he did an experiment, brought a bunch of experiments on board with a couple of other scientists, and they did experiments on the Virgin Galactic flight on Friday.
That's so good to hear. I was able to attend a New Commercial Space research conference a number of years ago, and space agency after space agency said that they wanted to leverage these tourist flights to do science that didn't require orbital, but otherwise wasn't going to get done. And this is finally showing that promises made, or at least occasionally promises kept.
Yeah.
All right, so we actually only have 2 minutes left because we're about to go and tour our Mars base being built in Minecraft, which is this absolutely amazing terracotta badlands that World Editor was invoked to get rid of the lava and the water and the dead bushes, and it looks like Mars. And I know your kids were like hardcore Minecrafters in the day.
Still kind of are. Well, one of them is still kind of.
You should get them the link to join our server. See if they want to help build Mars. Well, no, Mars is built. Help build a research base on Mars. So for folks who haven't seen you before, where can people find you and follow all the amazing things that you do in astronomy and space science?
Yeah, so I'm the publisher of Universe Today, which is a space and astronomy news website. And of course, I'm the co-host of the Astronomy Cast podcast here with Dr. Pamela Gay. And then, of course, I do my own podcast, as well as a lot of interviews, news, question shows, a lot of stuff on my own feed, a YouTube channel. I think the thing that I think people will enjoy the most is, well, depending on their personality, but I write a gigantic email newsletter every Friday that I think people like 30 or 40 stories about stuff that's happening in space and astronomy. And so that is, it is definitely something to keep you busy for a while.
It is a moose.
Yeah. And it just keeps getting more comprehensive. It was funny. One of my writers yesterday, Matt, was like, so are we just doing journals now? Because we've been reporting so much on interesting research out of journals and out of archive and conferences. And so, I mean, at this point now, I would say half of the stories that you see on Universe Today, you're not seeing anywhere else.
Yeah, it's amazing.
We are the most comprehensive. We don't cover a lot of boring stuff. We just cover stuff that I consider to be interesting. It's crazy. We were talking about like our being side by side with the Voyagers. So I started Universe Today when I was 27 years old.
Oh, jeez.
Yeah, and so I'm about to hit 25 years of Universe Today in March that I've been doing the same job for.
And we had Nancy on earlier talking about she's been 20 years with Universe Today, and that's how she just started. And there's a lot of sharing of humans between our different projects.
Our turnover on Universe Today is like, well, I don't know. I mean, very, very low. I mean, most of the writers who work with us have been working with us for decades well over a decade at this point. Or they go on and get really amazing jobs. Like Ian O'Neill is one of the press officers at JPL.
Yeah.
Right. So it's great to see sort of all the writers who've worked with us in the past who've gone on to have amazing careers. But yeah, and I feel like we're just hitting our stride. Like I'm getting so much better at finding interesting stories, telling these stories, and getting the word out. So yeah, that's Universe Today.
I really love it, and all of you should too. Check out universetoday.com and Universe Today pretty much anywhere that Fraser has decided there is an audience for astronomy.
Right. Yeah. Yeah. We're even in your dreams. Yeah.
Yeah. I fear that may sometimes be true.
That's next. Yeah.
All right. So
okay.
without further...
So am I going to come back in 15 minutes? Is that the plan?
Yeah. Just in the other, I'll send you the link.
Okay. Sounds good.
Okay.
Thanks everybody. And we'll see you in 15 minutes.
All right, so we're going live to Minecraft.
It's on the diagonal doing it. Watch my camera, follow his audio.
Hold on, fixing the audio. I'm currently deafened.
This is on the diagonal.
I'm currently deaf.
We got you.
This is on the diagonal.
I'm currently deaf. We got you.
Okay, good. I am on Mars. We are up in the hills behind our lander rocket. The hills here are covered in very red sand, and scattered around are the rocks that are sort of the hallmark of the surface of Mars. We have some that are heavily metal, some that look like they're more rock and a little bit less metal, and some that, well, this one looks like it's even basalt. Mars does have some tectonic activity we found just this week, and basalt is an igneous rock produced by volcanic activity. So we might expect to find more of that on Mars now that we know that it is geologically active. But of course, to get here, we need one really big rocket, travel a long way. And for Minecraft purposes, we've made it possible to go inside the rocket. The rocket is mostly empty. Most of this space would have been for fuel to get the rocket off the ground, to get it here, and to land it safely. But if we go up into the top of the rocket, we can find where the crew was. We have some storage here at this level for things that had to be brought to Mars with the first people to arrive here on this mission. And then up here in the top, we have a very sophisticated control room with some couches where the astronauts and Mars colonists might have been lying down safely during takeoff and controlling what was happening on the way here. Let's go back outside. Fortunately, Mars gravity is much lower than Earth gravity, so we can fall a further distance with a little bit less of an impact. We still need to slow down a really large rocket, so we have a bit of the leftover parachute that helped descent. There might have also been a parachute to help bring in goods dropped from orbit. Presumably there is a spacecraft somewhere up there watching us, keeping an eye on things, and allowing us to maintain contact with Earth, even when Mars is not oriented so that one side is facing the Earth that we're on. Once we arrived here, we started having to build things. So we need some really large equipment to help us move the heavy objects. There might be lower gravity on Mars, but some objects are still large and cumbersome. So we need equipment to move things around, places to organize it, and machinery to move it into position. We also need airlocks to make it safe to go in and out. Mars' atmosphere is much thinner than Earth, and there's not a lot of oxygen there. There's some nitrogen, but more carbon dioxide than we're used to, and it's very, very thin and very cold. So all of the building here helps to keep the air in and the heat in so that the plants that we've got alive in here can continue to grow. This looks like it's an experimental station. We've got some minerals, we've got some living organisms trying to find out what will survive on Mars. And oops, looks like a few things didn't survive the trip. If we're going to set up a colony on Mars, we'll need situations like this where we find out what kinds of plants and animals can survive to make life possible for us on Mars. Because on Mars, there's nothing to eat, there's nothing to make oxygen, there's nothing to produce heat that's convenient for us, so we'll need to take all of that with us. And once we're there, we'll need places to store it. And it looks like over here, we have a deep storage system set up off here along some tracks. Let's follow this into the hill, presumably underground to protect it from radiation. Mars doesn't have a strong magnetic field like the Earth, or an ozone layer up in the atmosphere. So a lot of that radiation comes straight to the ground. But it looks like we have a few things starting to accumulate here in our storage so that we'll have stuff available for the colonists to build on Mars. Also, we'll have to build something to produce energy. We've got a solar farm started here with solar panels. Solar panels are fairly easy way to generate some power. They've already been used for rovers on Mars, so we know that they work there. They're usable. Just have to keep them free of dust, because the dust is everywhere. Looks like we've also got a building here that has been built a little bit larger with a little bit more space, but some dust has gotten in. Nice large space. Some storage here to move some things inside that need to be stored in an atmosphere. Places for colonists or scientists, people who are explorers to rest and recover, and place here in the middle to work. Got some collapsible work tables that can be put away to make more space when they're not needed. Someone is doing some mineralogy right here. Brought some of the samples from the surface to slice open and take a look at. Some rocks. Oh, hopefully no fires in here. That looks like that might explode. Let's head back out and head to some of the other buildings that people have been building here. If you'd like to help build or to come visit this in person, we do have a link that you can follow, or a QR code. That QR code is not on the screen at the moment. There it is. And that QR code will let you join this Minecraft world. You can help to build this world, or if you just want to come around and see what's here for yourself. You're a Minecraft builder or someone interested in space and you want to see how are these things built in Minecraft. You can do that. We have here a rover explorer like Oppie and some of the other rovers that have been recently exploring Mars. Got places on the back for the maneuvering arm to put samples and solar panels to help it recharge while it's traveling long distance across Mars. To help get that colony going, though, we will need some minerals. And over here, looks like we have a mine started. Big crane arm over the top to let us lift things out of this deep hole. Looks like we've got some granite. That would be another, well, originally an igneous rock, but it would be metamorphic. It would have been buried under the ground and come back to the surface. Looks like there's some gold and, oh, is that coal? Coal comes from organic matter. That might mean there was some sort of life on Mars in the past that got buried. Coal is a fossil fuel, but it's a fossil fuel because fossils are evidence of life. So if there is coal on Mars, then that would be evidence of life. But coal is usually found underground because it's transformed organic matter that's been buried for a while. Here we have a future home of an aquarium and a research center. We go up the side, we can see there's a large water tank here. They might be putting fish directly into this, or there might be research equipment that needs to be placed into the water. Water helps to sort out some kinds of radiation, and so it can be used to protect equipment that are trying to detect certain kinds of cosmic rays or particles. It does look, however, that this is a biological research station. If I look carefully in there, I can see some kelp. Kelp might be a food resource on Mars because it is one of the fastest growing organisms on Earth. It's not a plant, but it's a protist. It's a kind of living thing that photosynthesizes like a plant, but its chemistry is different. And because of its rapid growth, it might be useful as a building material, as a source of sugars and other organic substances. Over here, we've got a greenhouse of sorts. This one looks like it's growing mainly food. We've got, that might be a pumpkin plant there, might be watermelon. It's hard to say without the fruit. They look very similar. We've got carrots and beets, potatoes. You've got to have potatoes on Mars. Mars needs potatoes. And over here, we've got our library. We've seen this a couple of times. Place to get away from all of the dust and just sit with a good book and look out at what's being built on Mars. Maybe look up some information that's needed. We've got a satellite dish here that will allow us to get information from Earth and presumably would take a good intellectual database, but sometimes you just need to look things up in books. Not everything has been digitized yet. Over here we have a garden. This one may be a more, well, recreational place, but almost every space that's going to be used on Mars will probably be of some scientific interest, even though we have just flowers here that might be for people to come and see or to produce oxygen for the people who are here and planning to live. We can still learn from what we're doing with these plants. Get back out here. One of our more recent buildings is this one right here, built in red stone. We have some astronaut suits ready for people going in or out. This looks like it might be another research center. People writing and reading papers, working with various minerals. Someone here has brought back some of that coal to take a look at it, try to find out more about it, maybe run some chemical analysis, and more research books. Always have to have those. Now, we're not just building this just for fun. All of this is part of advertising what we do at CosmoQuest. At CosmoQuest, we try to bring science to the public. Space science, planetary science, and make that accessible in a way that more people can know what's happening. There's a lot of research happening, but sometimes it's hard to understand. So we have various podcasts and broadcasts that allow you to see what's happening, ask questions, and understand. But to make all of this possible requires funding. If you can give, we would really appreciate it. That funding will help keep going the information to the public, information to you, and if we get enough money, we'll be able to reinstate some programs that had to be cut. Times are a little bit tough right now. We know that. And we've had to make some cuts at CosmoQuest. But we're hoping to raise at least $10,000 over this weekend. That way, all of the programs that are currently in place will continue. If we raise more than that, if we get back to $30,000, we'll be able to reinstate some of the programs that had to be cut. But CosmoQuest does rely on your dollars. So if you can give and give generously, we would really appreciate it. Looking at the time, we're at about the time for the next panel. Is the next panel ready? If so, I think we can transition.
All right. I am throwing to fundraising while we wait for the last two people. So tell folks we're going to Rockets or fundraising. All right.
Okay, we're going to go to fundraising right now.
Hello, everyone. I couldn't have said it as well as On the Diagonal did. We are working on always growing, always innovating, always doing new things. And we do this because we love to. We do this because we want to put more science into the world that is Creative Commons, free for all to use, share, consume. But we also have bills to pay and pets to feed. And we try to feed ourselves periodically. So we currently have a missing audio device that I need to reinstate before the next segment starts so that, sorry, I'm producing and talking and on stream all at the same time. And I'm having happen to me what has happened to Allie so many times today. So we're a tiny team. You get to see all of the sausage being made, all of it being made right here, live, on air, for your viewing amusement. Can we go with amusement? All right, so we now have audio going out. Fraser is back. I'm not sure if Beth is going to make it in this session. So before I switch over to everyone who is in this next panel, I just have to say, first of all, to all of you who have given, thank you so much. We are currently sitting at $3,155 in donations and 16,561 palindromic bits. Altogether, that puts us at about $3,300. And that is a third of the way to where we need to be. Yeah, all I can do is sigh and say, let's go get some science on. So I'm wrapping up the last YouTube stream. I am priming